Hello and welcome. So, we have to look on this system and make a good design. One of the methodologies is methodology that taken from the IEC 61508 that is functional safety of electrical, electronic, programmable electronic safety-related systems. That is based on V-cycles. When we start on the very beginning, we start with the system requirements and system design, then we make our system analysis. Safety analysis that makes a possibility to make a software requirements, software architecture design, software design implementation, and the second part of the V-cycle that is the checking functional that checks integration and software testing, verification of software requirements, and testing and integration of whole system. In this presentation, we show you the first two elements. As you saw at the previous slide, the first thing which we should take in our minds when we want to create a new system are the system requirements, which is the base to create and develop the system. It tells us what we should have in our mind when creating it. For example, it shows us how the car should be developed and why we need some functions and some parts of it. So for example, there is an external telemetry system given by the shell which have possibility to switch off the car. There's also having to be, for example, switch that can switch off the car during the race. So we developed such requirements, and they are based on our system. And this takes us to the user case diagram, where we have actors that makes much more complicated user case diagram. As you see, except to the driver, we need additional actors, that is the engineers, and also the judges. And there are some much more actions performed by them to act on the vehicle subsystems. And the next thing is the vehicle architecture. Here is the functional diagram, which is divided into three parts by the color. And the pink part is mechanical design of our car. The blue part is devices from the shell, our competition organizer, and the green part is about the safety system. They gather all the information that is needed in the system or the functions that you see in the previous slide. So, this is not only this action, but this is divided by the three subsystems. The same can be seen here in internal block diagram. This is the architecture of our car, and we can divide it in three parts. So, as I said before, the first part will be the pink one, which is mechanical design of the car. The second part is the blue one, which are devices, given by the organizers. And the third part, the most important for us, is the safety critical system. You see, this is not only the parts, but this is also the flowing of information, flowing the energy and flowing the hydrogen. For example, shown in here in the blue. Of course, this is the main system, where each of these elements can be subsystems. So, the first subsystem is about the putting the vehicle in the move. So here we have all the parts needed to do that. For example, the hydrogen storage, which is also divided for the fuel cell and things needed to use it. Also, we have the DC-DC converter or energy storage, which is supercapacitor. The diagram shows the flow of the data and of the power. The second part is the diagram with devices from the organizers. And this is mostly the data flow, but it also measures the hydrogen. And the most important for us is the safety critical part, which is a lot of devices controlled by the master controller, which take care of all the data and the information in the system and also send the energy to subsystems. As you see, this is the main element that we will focus in the second part of our presentation. All of these diagrams are created in Ansys SCADE architecture and allows us to better understand the system and better to design it. Thanks for watching.